decided what the purpose is. Now we are designing the structure. First thing is provide provision for mechanically breaking down food. What are the provisions for mechanically breaking down food? Where all mechanical breakdown of food happens? In the mouth by chewing. So you have this designed to break down food mechanically. How powerful it is realized when accidentally you bite your tongue. Okay? How powerful is this motor is realized when you bite your tongue accidentally, especially when you bite it in between your molars. Suddenly you will start seeing stars and God also. Alright. So it's very powerful. Where else? Stomach is also designed for mechanically breaking down. The churning will lead to mechanical breakdown. It is also designed, the second design element that we have to think about is hold, to rest it and pre-treat it before chemically breaking it down. Where else does it hold? Stomach. Stomach is therefore designed like a pouch. It's like a bag. It's a muscular bag. What is the shape of the stomach? How do we call it? We call it a J-shaped muscular bag. And because food is being held there, we are holding it. We are not letting it pass. And we don't have control on how much we eat. We want to feel satisfied while eating. So stomach is designed to allow for that also. Stomach has been made stretchable. It can stretch. Alright? It can stretch and accommodate more food. That is one part of the digestive system we exercise a lot, isn't it? We don't feel like eating until our stomach tells us, I can't stretch anymore. Please stop. Alright? Especially when you go to functions, parties, you will not listen to anybody but to the cry of your stomach. Your stomach should cry, not just telling you. First stomach will tell you, I think I am done. Go, I have just started. Alright. By the time you go to the ice cream, stomach is telling you, no, I will burst off. Then you will take some kindness on the stomach. We used to do this. During our MBBS days, we were a small group of friends. Otherwise, I don't remember dates and names and all. But somehow we would get to know somebody is having their birthday. And we will also accidentally happen to be in the same place for lunch where they are giving party to their friends. It's not like we planned that. Accidentally we will also go there for lunch. And if your classmate is around and you are giving birthday party to somebody, we wish them there only, not in the class. They have to give you party. But by then we would have already finished our lunch also. We don't want to make them feel sad because they are giving a party. We have to eat properly. And even marriage parties, friends, brothers, brother-in-law, we don't bother who it is. We don't want to make anybody sad. We just go. Alright. So stomach is designed to be stretchable also. Small intestine is designed to have powerful chemicals for digestion. So major chemical digestion happens in the small intestine. Large intestine is designed to be the dumping place for wastes, slowly push through the loops. So large intestine is also designed to be stretching, because we don't know, sometimes there might not be enough water, the nature of the waste might be not smooth enough to pass through the large intestine. So it is also stretchable. But large intestine, because it has undigested food and waste, and there are a lot of bacteria in the large intestine, you need to create mechanism of irreversibility in flow. So wherever you want something to not come back, you will design valve. Valves will ensure that there is one directional movement. Wherever you want strong grip, you want to close and open strongly. Wherever you want to close something strongly and open it only with regulation, you will have sphincter. So in this entire design, you have tubes of varying sizes, varying functionality, varying stretchability throughout, and you have sphincters and valves. Where all do you have sphincters, tell me? Starting from mouth to anus. The tube goes like this. There is mouth, esophagus, stomach, small intestine having three parts, duodenum, jejunum, ileum. Then small intestine opens into large intestine. You have cecum, colon, ascending colon, transverse colon, descending colon, sigmoid colon, rectum, anus. Attached to the cecum is a vestibular organ, vestigial organ, appendix to the cecum. This side. Between the ileum and the cecum, what do we have? Valve. What is that valve called? Ileocecal valve. A very important valve. There are other things also connecting to this. There is liver connecting to the hepatopancreatic duct. There is pancreas also coming with the pancreatic duct. Liver comes with the hepatic duct. Both of them join together to form the hepatopancreatic duct. There also you need to have sphincter, you need to have valve, because the fluid from this duct coming from pancreas and liver should get into the small intestine, to the duodenum, not the other way. Food should not get into the pancreas or the liver, correct? And from the liver also, bile is produced in the liver, it comes into the ductal system, which gets stored in the gallbladder. It should not, when gallbladder, how is it releasing bile? It is squeezing. While when the gallbladder squeezes bile, it pushes bile upwards. The duct which is bringing bile from the liver to the gallbladder, there you should have a valve. Otherwise, what will happen? Bile will backflow into the liver, which should not happen. So it will go, hit the valve, come into the bile duct and goes and joins the, not the bile duct, hepatic duct, and goes and joins the hepatopancreatic duct. That's all. So you have two valves here. One protecting the liver from having a backflow of bile. Another one in the, at the junction where the duct coming from the gallbladder meets the hepatopancreatic duct, so that fluid should not go here and there. There is one duct which protects the hepatopancreatic duct, which is at the valve, which is at the junction between the hepatopancreatic duct and the duodenum. Are you understanding? You don't have to remember anything, just visualize the design. Just visualize the design and make sense of the design. There should be a valve. You cannot have a sphincter. Can we have a valve between the stomach and the small intestine? Can we have a valve between the stomach and the small intestine? Valve is like a flap, functions on pressure. When we load up the stomach, because of the pressure of food in the stomach, valve will open. It will not hold. Valve is not powerful. It can only prevent backflow. If there is pressure, it will open. When there is a threshold of pressure. If you want to make the junction of stomach and small intestine tight by having a valve, you need to have a valve which can withstand the force of stomach churning. Stomach is a very powerful muscle. It's churning with the food inside, it creates a lot of pressure. So what makes sense for you to design? Does it make sense for you to have a valve there? It makes sense to have a sphincter. Tightly it can close. Sphincters are always around. There is a tube. If this is the tube, the sphincter muscles are designed to be around this. So when the muscle contracts, what will happen? It will squeeze. When the sphincter muscle relaxes, it will elongate, making the pressure release on this tube. Contraction causes the muscle to become shorter. So when it becomes shorter, it will squeeze the tube. So we need to have sphincters between the stomach and the small intestine. Yes or no? Where else do you need to have sphincters in this tube? From mouth to anus, tell me the places where you need to have valve. Forget about pancreas and duodenum, liver right now. Think about only the tube. Where do you want to install a valve? Non-return valve or a one-directional valve. Where do you want to install valve? You are the designer now, you are designing it. Think about it that way. Where do you want to put out a valve? And where do you want to put the sphincters?
common line between food pipe and
The junction between the food pipe or the esophagus and the stomach. That also needs to be protected. What do you need? You need to put a valve there. Sphincter. So at the beginning of the stomach and at the end of the stomach, you need to have sphincter. So we have one sphincter between esophagus and stomach, one sphincter between stomach and duodenum. Name the sphincter now. Give it a name. Naming also is with some logic only, no random names. This is esophagus, this is stomach. You know Maruti Suzuki. Why is that name given? Why is that name given? Huh? It's a collaboration between two companies, Maruti and Suzuki. Suzuki is a Japanese company. Maruti is an Indian company. Maruti Motors. Now is it Maruti Suzuki? The collaboration is over now. It is no longer Maruti Suzuki. The name here now is Maruti only. So now you have a sphincter between esophagus and stomach. You have to name it. What will stomach say? Will it agree? If you say esophageal sphincter, will the stomach agree? Because there is no collaboration. The partnership has ended. You still have partnership, no? When the partnership is still functioning, you don't give the name to your partner. Problem. Business will not run properly. Okay? You have to make sure money and credit is properly shared. Don't let anybody take money that belongs to you. Don't let anybody take the credit that is due to you. And you don't do that. Don't take somebody's credit. Don't take somebody's money. Then you will do good business. Now, you cannot call it esophageal sphincter. What do you have to call it? Can I say stomach sphincter? Esophagus will get out of partnership. It will threaten. Huh? Esophago-stomach sphincter. Doesn't sound technical. It should sound like it is very technical. Common people should not understand it. All right. You should not say food pipe stomach sphincter. You should make it complex. It is correct. It's technically, actually it is food pipe stomach sphincter. If you say that, nobody will respect you. All right. Now you are all taxonomists. You are all people who are sitting here to decide what name to give. Now we understood it. The food pipe and the stomach, both of them should have a share of the name. But we cannot keep it as food pipe and food pipe stomach. Sphincter also, right? You can say band, no? You can say food pipe stomach band. You will not have respect. You should call it sphincter. Then somebody will come and ask you, what does that mean? Then you'll say, you don't know that much? I'll tell you. Okay? That is how you build some image of being intellectual. Now tell me, okay, esophagus is on one side. Give some other name for stomach. What is the juice produced by stomach called? Do you call it stomach juice? Huh? Think about it in your mind and then come up with the full word. You should not say gas. Okay. Gastric juice. Okay, now name the sphincter. Gastroesophageal sphincter. Sounds good. It's gastroesophageal sphincter. All right. Now, fits well. All right. We can later decide on who will get the name for naming it. All right. Whoever is the senior most will become the first author of the name. All right. Okay. The sphincter between stomach and duodenum. You can also say first part of the small intestine, duodenum. Duodenum is the technical name. You have stomach and duodenum. There is a sphincter between stomach and duodenum. What name we can give it? Gastroduodenal sphincter. Stomach also has been given 5 parts. Stomach has 5 parts. 5 parts are named. Pyloric sphincter. The last part of the stomach is called pylorus. So, pyloric sphincter. Pyloric sphincter. This gastroesophageal sphincter is also called, this part of the stomach is closer to the heart. What are the 5 parts of the stomach? Can anybody say? This is cardia, or closer to the heart. Then the bulged portion is called fundus. Fundus means the bulged part. Then you have body. Then isthmus. Cardia, fundus, body, I think isthmus and pylorus. So the sphincter is present in the cardiac region of the stomach. So you call it cardiac sphincter. So if the question is cardiac sphincter, you should not think that it is something related to heart. Cardiac sphincter is the gastroesophageal sphincter. Pyloric sphincter is the gastroduodenal sphincter. Okay, where else do you need sphincters? Okay, if we keep going down, do we need any valve or sphincter in the small intestine? Through the length of the small intestine? We don't need it. Let it pass. Then we come to the junction of small intestine and large intestine. What do we need there? Do we need a sphincter? Do we need a sphincter? It has already passed so much distance. Why do you want to hold the contents there? You just want to let it pass. But what you should ensure, there is no backflow. Whatever passes out should not come back. So what do you need there? You need a valve. What valve? Name it now. It is a valve between the last part of the small intestine and the first part of the large intestine. You cannot call it small intestinal, large intestinal valve. Sounds very laymanish. Okay. What is the last part of small intestine called? Last part of small intestine is called what? Duodenum, jejunum, ileum. Okay. First part of large intestine? Cecum. You have cecum, colon, rectum, anus. Anus is the end of rectum. Okay. So the valve is between the ileum of small intestine and the cecum of large intestine. Now we are moving further. Name it. What do we name it? Ileocecal valve. Okay. Ileocecal valve. Sounds good. So ileocecal valve. Going up, do you need any valve or sphincter in the colon? Ascending colon, transverse colon, descending colon. Do you want to hold items there, or you want to let it pass? You want to let it pass. Finally, what the wastes reach? Where do the wastes reach? They reach the rectum. The opening at the end of the rectum is anus. Do we need any valve or sphincter anywhere? Anus. Do we need a valve there? We need to have sphincters. Imagine what would have happened if there were valves. Okay, if there were anal valves, problem. Sphincter. There are double sphincters there. 2 sphincters. Internal sphincter and external sphincter. Very sensible, no, nature. Evolution has anticipated that there will be 3-hour classes, 3.5-hour exams. All right. So double sphincters, internal anal sphincter and external anal sphincter. That's all. This is the entire design. Design is over. Design of the tube is over. We have attachments there for the tube. The attachments are glands which will produce chemicals which will break down the food completely. Where all do we have glands, and tell the names of the glands? Do we have glands in the mouth? What do we call those glands? Salivary glands produce saliva. What are the types of salivary glands? Do you remember? What are these glands here? When they swell, when they get infected by a virus, you will have swelling, dry mouth. What is that virus? Mumps virus. So this salivary glands will swell up. What is this salivary gland here behind the ear, or inner to this part here? Forgotten. Parotid gland. It's okay. We'll all remember parotid gland. Then you have submandibular gland or submaxillary gland. Then you have sublingual gland under the tongue. Sublingual gland. Now all of these glands have ducts through which the secretions come into the mouth. The ducts also have names. We'll see that later. They are the factories. They will produce saliva. They will pump the saliva through pipes into the mouth. Over. There are 3 factories there: parotid, submandibular, and sublingual. That's all. Do we have glands in the esophagus? And from the mouth to the esophagus we have pharynx. Just a passage. Esophagus, do we have glands? No glands. Esophagus is just a passage, muscular package. In the stomach, do we have glands? What do we call all the glands in the stomach put together? Gastric glands. Gastric glands also are of different types. We have different types of cells in the gastric glands. Can you name some cells? Chief cells, parietal cells. No, forgotten. Okay, gastric glands are there. What do they produce? They produce gastric juice. Gastric juice will have various chemicals. That's all. Enzymes and non-enzymes also. One of the very important production that happens in the gastric gland is hydrochloric acid. Hydrochloric acid and enzymes. Over, done. Then come to the small intestine. Who all contribute to the chemicals that will digest in the small intestine? The chemicals of digestion or the enzymes of digestion are produced by which glands associated with the small intestine? You have pancreas producing pancreatic juice. Pancreatic enzymes are the most powerful. You have liver producing bile juice or bile. No enzymes for digestion in the bile. Bile has a different function. Its role is to emulsify fat. What is emulsification? All of that later story. Then you have intestinal glands. Duodenum and jejunum have glands. High concentration of digestive glands. You call them intestinal glands. What do they produce? They produce a juice called intestinal juice. And when we were doing all this, we felt very uncomfortable. We wanted to make it more complicated. Okay? Intestine is also called enterum. Enterum. Enteron is intestine. Okay? Coelenteron. You have coelenterata, platyhelminthes and coelenterata. Coelenterata, what is the advancement in them? The advancement in the coelenterata is they started developing an intestine. Digestive tube started forming in them. Platyhelminthes, you don't have a well-formed digestive tube. Platforms, no digestive tube. Enteron means intestine. Juice or a fluid, there is a Latin or Greek term for that which is called succus. Succum is fluid. So intestinal juice, somebody raised their hand. They said, we'll complicate it. We'll call it succus entericus. What does it mean? Intestinal juice. Succus entericus is juice of the intestine, which you can call in simple English as intestinal juice. Further simple, some chemicals produced by the intestine which will digest food, all mixed in water. Alright, it's like Glucon-D. There is powder, there is water. You mix it, you have juice. That's all, no? None. Large intestine, no enzymes. So, the design we have decided, design is the tube and the glands. Function is glands, the different parts. There is mechanical breakdown of food, there is chemical breakdown of food. Mechanical breakdown happens in the mouth. We need to understand the design of the teeth, what kind of teeth will contribute to what kind of breakdown of food, contribution of tongue, stomach, the movement of that stomach. What are the folds in the stomach called? You remember? Stomach is folded. What do you call the folds in the stomach? Rugae. Okay. Remembering that the stomach has folds is important. You should not forget that. What is it called? You can forget. You will forget if you don't revise. It is called rugae. R-U-G-A-E, rugae. Now we have glands, liver, pancreas, intestinal glands. For the digestion in the small intestine, liver, pancreas, intestinal glands are important, these three. For the digestion in the stomach, gastric glands are important. For the digestion in the mouth, salivary glands are important. We have three nutrients, we have three food sources which needs to be digested. What are the three food sources that needs to be digested? Carbohydrates, lipids and proteins. Different foods are digested in different places. Small intestine is the place where everything is digested. All the three digestion happens in small intestine. Carbohydrate digestion does not happen in the stomach. Protein digestion does not happen in the mouth. That's all. So mouth can do partial digestion of carbohydrates. Mouth can do partial digestion of lipids. Stomach can do partial digestion of proteins, and stomach can do partial digestion of lipids. So if you see, lipid digestion to certain extent will happen everywhere. Mouth, stomach and small intestine. In the mouth you have lingual lipase. Lingua is what? What is the reference when I say lingua? What am I referring to? Referring to tongue. Bilingual means what? In two language. Multilingual, multiple languages. Alright. Sublingual. Sub means under. Subway. Underground. Subway means underground. So subway in America, what they mean is underground network of rail. That's all, no? Lingua is tongue. Lingual lipase. ACE. When something ends with an ACE, A-S-E, it means it is something that's an enzyme which breaks down. Lipase is a reference to lipid breaking enzymes. Lingual lipase, gastric lipase, pancreatic lipase. That's all. Carbohydrate digesting enzymes are called what? Amylase. Amylose is a carbohydrate. Amylose is the structure there. Amylase, salivary amylase, pancreatic amylase. There is no carbohydrate digestion in the stomach. Protein digesting enzymes are called proteases. But proteins are complex structures, primary structure, secondary structure, tertiary structure, quaternary structure. What we consume mostly are quaternary structure proteins. So proteases, proteoses, all of those are there. So in the stomach you have two enzymes which will break down proteins. What are they? Pepsin, renin. Pepsin and renin. Renin is for digesting milk proteins. Pancreatic enzymes. Pancreatic enzyme. What is the pancreatic enzyme for protein digestion? Trypsin, chymotrypsin. Pancreatic enzyme and this thing. Alright. Trypsin, chymotrypsin in the small intestine. So pepsin, renin, trypsin, chymotrypsin. These are the enzymes which will act on proteins. In the small intestine, disaccharidases also act. You have to break down into monosaccharides, no? You have to break down the carbohydrates into glucose, fructose, lactose. But glucose plus glucose is what? Glucose plus glucose is maltose. Glucose plus fructose is sucrose. Glucose plus galactose is lactose. Right? So you have the enzyme which will break down maltose. What is the enzyme? Maltase. The enzyme which will break down sucrose, sucrase, It is also called invertase, invert sugar. Sucrose is also called invert sugar. So if a question comes where a reference is to invertase, it is sucrase only. Invert sugar, it is sucrose. Alright. Enzyme which will break down lactose is lactase. That's all. Some people have lactose intolerance. Heard of it? They drink milk, they will start having diarrhea. Why should milk cause diarrhea? Formation of lactic acid in the stomach? Stomach will not act on milk, lactose only. Stomach will act on milk protein. What is the milk protein? What is the milk protein? Lactose is not the milk protein. What is the milk protein? Lactose is carbohydrate. Renin acts on what? Milk protein is casein. Okay? Milk protein is casein. Pepsin acts on casein. In the stomach there is action on casein and the fats of the milk. Partial digestion of fats happen. When the lactose comes into the small intestine, milk carbohydrate, absence of lactase enzyme or deficiency of lactase enzyme will make the lactose remain in the stomach, in the small intestine, and it passes. So that will also bring about osmotic effect. Osmotic effect can be brought about. Some people can develop allergies to lactose. The digestive enzyme is not able to break that. Some people might develop an immune response to lactose, causing allergic response also, increasing further accumulation of fluid in the small intestine, leading to diarrhea. So somebody is having milk and they are having diarrhea, they should stop having milk, that's all. Alright. Children drink milk, their intestines are also not very long, but their milk gets digested because renin is an enzyme specialized in acting on casein. So stomach also participates in milk digestion in children. But as we grow older, renin production comes down. We will not be having enough renin to contribute significantly to milk digestion. But we will still tolerate milk very well. Why? Small intestine has it, no? Trypsin and chymotrypsin. Right? And there are two more enzymes, protein digestion enzymes, carboxypeptidase and aminopeptidase. Forgotten? Protein digestion will be understood when you understand the structure of proteins. Alright? But right now, end of the story, function, design, purpose we understood, design we understood, function, all the three different types of food containing our nutrients have to be broken down into its constituent mono units, single units or constituent units, and made available for the intestine to absorb. That's the function that needs to be performed. So breaking down is the function, basically. Breaking down to its minimal structures. Chop it to pieces where you cannot break down it further. Do it mechanically, do it chemically. What is the design for mechanical and what is the process for mechanical breakdown? What is the process for chemical breakdown? What happens in the mouth? What happens in the stomach? What happens in the small intestine? Three types of enzymes: amylases, lipases and proteases. Salivary amylase, pancreatic amylase, only two amylase. Three lipases: salivary lingual lipase, gastric lipase and pancreatic lipase. Alright? And pepsin, renin, trypsin, chymotrypsin, aminopeptidase, carboxypeptidase. 6 enzymes for protein digestion. That should tell us the complexity of protein structures. When you look at the structure of the nutrients, carbohydrates, lipids and proteins, Proteins are multi-level structure. They go up to quaternary structures. All right, that's all, over. Function, done. So, purpose, design, function, one system, over. All right, any questions, any concerns, anything that you want me to tell again? Some things might have gone over the top in the context of... Okay. Purpose, design and function. Look at the system in your own mind within these three frameworks. Okay. Digestive system done. What do we take next? Circulation. All right. Circulation. Yes. What about roughage? We discussed that roughage is not nutrient, but we need to have it. Why doesn't the roughage get digested is the first. It doesn't get digested. Why? If it doesn't get digested, it is not contributing to our nutrient requirement, then why should we have it? Those are the questions with roughage. It doesn't get digested. Roughage is what? What are we referring to as roughage? Cellulose. Cellulose is the carbohydrate that we are referring to as roughage. The structure of cellulose is also a polysaccharide, no? Starch is also polysaccharide. Cellulose is also polysaccharide. Starch is also made of repeating units of glucose. Cellulose is also made of repeating units of glucose. Then why is it that we can digest starch but we cannot digest cellulose? The structure. All right. I want you to go back and just observe the structure of starch and cellulose. Cellulase. No, but why? If it is a polysaccharide made up of repeating units of glucose, which starch also is, we can digest starch by amylases. Why can't we digest cellulose? So, at the outset, understand that cellulose has a different structure. The arrangement of joining glucose in a series is different in cellulose, which makes it impossible for the amylase to access the active site. So, cellulose cannot find an active site on amylase. Starch, because of its structure, has an active site on the amylase. Cellulose has a different structure which cannot fit into the active site of amylase. It fits into the active site of the enzyme called cellulase. Cellulase is found in ruminants. All right. Now, one thing. Then why do we have to eat it? Why do we have to eat it? Cellulose adds to the bulk of our food. It adds to the bulk of our food. We feel heavy. We feel full by consuming cellulose. One of the risks associated with our diet is we tend to eat more than what our body requires, which leads to other complications of our body unnecessarily storing excess calories in the form of glycogen initially and then fats in the adipose tissue. So, cellulose consumption, roughage consumption along with our food will fill our stomach. Roughage also expands by absorbing water. When the fibers go into the stomach, it will absorb water. It will be broken down into further fibers by gastric acid. Gastric acid will act on the fibers. What was compact now will start becoming thread-like, more thread-like, stretching out and becoming bulkier. We cannot call it a system. Mechanism we will say. The cell also has a mechanism of digestion. The cell has mechanism of circulation. The cell has mechanism of excretion. Movement, locomotion also is there in the cell. Those amoeboid movements, those change in the shape of the cells. All right. There is excretion responses also. There is respiration also happening at the level of the cell, gas exchange. See? What we see at the gross level is designed to support the same process happening at the cellular level. All right. So how does that happen within the cell is what we have to look at it a little bit more deeper when we go into cell biology further. All right. So this is the picture. We have to go into a little bit more detail of every system now. I told you purpose, design, action. We will look at something of the purpose, design, action for all the systems in the rest of the session. All right. Do you need a break? 5 minutes? Okay. Which is 11:08 now. I'll give you 7 minutes break. 11:15 we will reassemble. Anybody wants to just stretch around, walk around, have a glass of water, go to the washroom, whatever you want to do. 7 minutes. So good, everybody is back on time. All right. So let's start with purpose, design and action of every system. Not more than 10 minutes for every system. Alright, let's see, quickly we'll do it. Or let us take some time, it's okay. Purpose of digestive system. Quickly tell. Purpose of digestive system. What is the purpose of digestive system? It should be here. What is the purpose of digestive system? To break down complex food into nutrients. That means what is the food that we consume? What will it contain? It might have complex carbohydrates, complex structure proteins, and lipids, fats or oils. So to understand what it will be broken down into, how it would be, all of that, we need to have a bit of biomolecule background. What is the structure of carbohydrates? What is the structure of protein? Primary structure, secondary structure, tertiary structure, quaternary structure. How does it break it down into different fragments? All of that will help us understand the breakdown of the food, the transformation of food from food to nutrients. But here we will just focus on what the digestive system does. Alright. So we consume food in a complex manner. 5 things that are required by our body are present as a part of food. What are the 5 things that are required by our body in terms of nutrients? Carbohydrates, proteins, lipids, vitamins, minerals. 2 more things need to be added to our diet. What are the 2 other things that need to be added in our diet, which are not nutrients but necessary? Water and fiber, roughage. So diet, your food should contain 7 components: carbohydrates, protein, lipid, vitamins, minerals, water and roughage. Every meal should include all 7. Every meal should include all of this. Alright? But nutrients are 5 in this. Of the 5, digestible nutrients are 3. 2 nutrients need no digestion. Vitamins and minerals need not be digested. They just have to be released from their attachments. You release them, they will get absorbed. So food as such, you will not get carbohydrates separately, protein separately, lipids separately. It's all mixed up together. So when everything is mixed up together and you want to break down everything into its components, what you need to do, how will you design the system, how will you design the mechanism to break it down into its micro components which can pass through the gates of the small intestine. What can we call those gates as? Channels. The channels of absorption. Okay, different nutrients will have different types of channels. And again, when we go deeper into that, each type of channel will have different kind of mechanism. Something will allow that particular substance to pass unhindered. Something will require somebody else to accompany this fellow, like glucose. Glucose is dependent on something for absorption. What is that something on which glucose absorption depends? Sodium. So glucose is transported by channels called glucose transporters, GLUT, GLUT. There are different types, GLUT1, GLUT2, GLUT3, GLUT4, goes on like that. There are multiple variations of the glucose transporters. All the glucose transporters are dependent on sodium. It's like a gate. Sodium is like the key which will open the gate. Without sodium, glucose will not be able to pass this channel. Now keep this information. I'll ask you a question for which you will have to think. Alright. Somebody is having diarrhea. His friend gives him he is having diarrhea and he's become tired. His friend gives him 2 glasses of Glucon-D. He has a Glucon-D packet. He takes that Glucon-D glucose powder, puts it into water, makes him drink. The person dies of dehydration. Why? What happened? That was supposed to give him energy, no? He has given water also and he has given glucose also. But why did this person die? See, these are questions where you have to apply the knowledge. What I told you right now about glucose transportation in the glucose absorption in the intestine should be enough for you to explain this. Is glucose an osmotic substance? Is glucose an osmotic substance? Like if we have two compartments with plain water and separated by a semi-permeable membrane. Both the compartments have 1000 ml of water, 1 liter of water, plain water. In compartment A, I will add 100 grams of glucose. What will happen in a period of time? Which compartment will have more water? A or B? A will have more water because glucose being an osmotic substance will pull water towards itself. It will pull water towards itself, making this compartment increase water content. Now consider this as the small intestine of the person. This as the blood circulation, blood. There is water in blood. There is glucose that has been put here. What was supposed to happen was glucose and water should have been absorbed from here. That would have got absorbed if along with glucose there was sodium. During dehydration, this fellow did not just lose water, he also lost electrolytes. He lost sodium, potassium, calcium, he lost various electrolytes. Now you give him only glucose water, glucose being an osmotic substance and there is deficiency of sodium. Glucose cannot be absorbed. Now this makes his small intestine an osmotic chamber, further pulling water from the blood and increasing the volume of fluid in the small intestine increases diarrhea. This kind of diarrhea is called osmotic diarrhea. Osmotic diarrhea is where an osmotic substance which is not absorbed in the intestine is causing pulling of fluid from the blood and leading to diarrhea. See, small things. Alright, understand? So, we will come back, we will not go further deeper. Now I will start going into glucose transporters, then we will go into osmosis, then we will go into different types of transportation. We will deviate. Let us not deviate, we will stick to purpose, design and action. Purpose, design, action at the surface level, not going too deep into it. Purpose is clear. Whatever we put into the mouth, it has to be broken down into its constituent parts. Are you okay to have undigested food? Are you okay to have undigested food and let it go? Anyways, it will come out, let it go. Are you okay with that? As a designer, think of yourself as a designer of the system which is supposed to break down food into nutrients. What do you want to build? Do you want to build a system which can break down as much as possible, or do you want to build a system which will break down every food into all nutrients possible? You want to make it an efficient system, no? Now it's a complex food matter that you are consuming. So it is entering a pipeline. The design is a pipe. It's a tube. It's a tubular design that you are giving to the digestive system. So on one end of the tube, food is entering. You have to make sure that the food moves in one direction. So you make the tube one directional. The design is unidirectional movement. But there can be reverse movement also based on pressure, vomiting. When there is a lot of pressure that is being built up in the stomach, it can cause reverse peristalsis. So to make the food move in one direction, what should you employ? Do you want to allow it to the grace of gravity? Anyways, we are standing, we will put food here, it will pass, it will go down by gravity. Can't do that, no? You need to have active mechanism of pushing food in one direction. So this tube has to be designed in a way that it creates a movement of something in one direction irrespective of what posture the person has. So what do you, if you want to push something or pull something, you need to create force. There are times when you want to go to a function in a traditional wear, you have your pyjamas and whatever you want to wear. You are ready, your friend is waiting, your family is waiting, and you see there is no lada in the pyjama. The pyjama has not got the lada. One end of it is come out. It's gone inside. Have you experienced these kind of situations? It has to have the thread, no? The pajama is tied with the thread. The dreadful situation is you have only one end of it. The other end is buried inside. In that whatever you call that. Now what do you do? What do you look for now? You look for a safety pin or something. Can you repair that without pulling the entire thread out? You have to pull the entire thread out, put a safety pin, and how do you take it to one end? You hold here, you push this, hold it here, pull it. Then hold here, push it, hold it here, pull it. This is exactly what stomach does, what the digestive tract does. Alright? It is squeezing on one side while it is keeping this side open. So things move further. Then squeeze here, keep this open and let this open, move here. Peristalsis, a wave-like continuous motion in one direction. So you designed that. For food, it has to go through one passage because you don't know, you cannot just allow it to enter the body completely, enter all parts of the body. It has to be regulated. You have to keep this food in one regulated compartment so that you check it properly and allow only what is required to enter the rest of the body. So you need to have a system, a tube which is not in continuity with the other parts of the body. It's a separate tube that we have put inside. Another problem is, because we are eating complex food, you need to give the food enough time inside the tube for it to be broken down. You just eat it and eat it from one end and the food comes to the other end in 10 minutes. Then you don't have enough time to process it. So you have to give time. If you want to give time to the food to pass, the design should be in such a way that the tube becomes longer. To allow enough time for the food to pass, you have to make the tube longer. Now if you make the tube longer, it becomes bulky. So you have to package it properly. You see this packaging. All the intestines are just packaged properly and pushed into the abdomen. So designing is done. The length you have designed, it is to be longer. You cannot just allow everything to pass continuously. You are holding it for some time. Where are you holding it? For mechanical processing. Stomach. Food goes into the stomach. For about 30 minutes to 1 hour, the food stays in the stomach. It will take about 2 hours for the stomach to completely clear. For about half an hour, the stomach will hold it. What is it doing? It is like a treatment chamber. Whatever you have it on, who knows? Use chemicals to make sure at least the things that can be destroyed by acid attack is attacked. Acid will loosen the food. Churning of the stomach will break down the food. You are supposed to break down food in the mouth significantly. But I don't know since when we have lost the habit of chewing food, we just swallow food. Correct? And we even pride ourselves in eating faster. I also eat fast only. Just take a big bite. So many times our esophagus will cry. It will cry in pain. It happens. No, you eat very fast and esophagus is crying, esophagus is stretched. Has this happened? You are eating very fast and suddenly you feel a pain in the chest. Esophagus is stretching and you will start hiccuping. Why did that happen? What is the connection between eating fast, esophagus getting stretched and hiccup? All unrelated things. And you drink water, esophagus settles down and hiccup is gone. What's happening? And does this happen more often during breakfast or during lunch and dinner? Breakfast, because esophagus has rested for a longer period. Breakfast to dinner, here I don't know, you are not getting enough things to eat, you are not allowed to go out, so you don't have food on your table at all times. But if it is at home, we have to consciously give break to our motors. Otherwise, there is something to eat always. Keep eating, like cows. Cows are regurgitating, they are just storing it once and they are taking it out and they are further processing it. We are just loading. Alright. And yes, find out why that happens. You will not be able to find out, you will not get it in your NCRT. There is a branch of vagus nerve which goes to the diaphragm behind the esophagus. Vagus nerve is which cranial nerve? Number? Cranial nerve number? How many cranial nerves are there? 12. There is a 13th one also identified, but it has not been added to the list of things. We will consider 12 cranial nerves. Vagus is which one in the sequence? No? 10th. Vagus is the longest parasympathetic nerve. So vagus passes through, a branch of vagus goes to the diaphragm. It is behind the esophagus. It is closely connected to the esophagus, behind the esophagus. When there is a sudden stretching of esophagus, that will irritate this vagus nerve branch that is going to the diaphragm right behind the esophagus. That irritation of the nerve causes twitching of diaphragm. What is hiccup? Diaphragm is kicking you from inside. Here, no? Just kicks you. That is hiccup. So when you drink water, that esophageal contractions, that esophageal violent contractions will settle down. The irritation of the vagus nerve branch supplying the diaphragm is subsides, and that will settle down your hiccup also. Anyways, the design, digestive system design, we'll come back to it. Alright, long tube, a tube which should have possibility of breaking down food mechanically, a tube which should have hold and pass kind of a system also, a tube where you should give enough time for digestion, a tube where you should have slow but steady unidirectional movement, one directional movement. So what all are designed to facilitate these things? We are are found in other parts of the book. So in terms of the syllabus as such, it doesn't reduce, but the number of chapters come down because of elimination of repetition. Alright. So, okay. Madam, Suchang Madam, can we give them access to the Bluetooth connections with all the tabs and share the PDF of all the latest NCRT books today? I will share it with you. You have your tab now. So, have you tried transferring files on Bluetooth from one tab to another? Is that possible? Is it possible? Bluetooth transfer of PDF files. Okay, then I will give it to both of your teachers. So in your respective hostel blocks, get all the 10 books on your tab. Cross check with that and work on your textbook, hard copies. Alright, that should help. Let there not be any additional irrelevant work. Let us do only that work which is relevant to your preparation. Alright, today by the end of the day today, all of you should have your textbooks on your tabs. So your job is to Like let's say one person from every room takes it from the teachers and you share it mutually. Possible, no? So if 10 people get it, the next 5 minutes 20 people will have it. Next 5 minutes everybody will have it. Alright, okay. Any questions, doubts, confusions, clarifications you need in the topics that we have discussed so far? Or related to that also, if you have any questions that has come into your mind, you can ask. While reading, you can make note of your questions. Whatever questions you feel like asking, you can make note of that. Have discussions amongst yourselves to get some clarity on those. And then if you feel you are stuck at that point, ask me or ask the teachers who will be there from time to time, the senior teachers or the resident teachers. All right. Anything? Clear so far? Okay. Good. How is the post-test analysis going on? Anybody completed all 90 questions? Analysis of all the 90 questions? Not yet. 50% of it? The first 45? Who has completed the first 45 questions of biology? Raise your hands. Oh, rest of you are still yet to catch up. You have only today left for doing that. Tomorrow we will discuss. Alright, today by the end of the day, if you can finish completing half of the paper, tomorrow I will discuss half of the paper. Then you will get tomorrow to complete the rest of the paper. Saturday we will do that. Okay. Saturday probably I will take your 6:30 to 8:30 session. I will take the class between 6:30 to 8:30 and 9:30 to 10:30 because I will leave in the afternoon. My flight is at 4:30 from Guwahati. So I may have to leave here by around 12:30. Alright. So we will manage it that way. But it will not be more than 3 hours of teaching. I have made some statistical analysis of the entire course. I will share it with you. There is no need to share the document with you, but I will just read out whatever we have compiled, whatever I have compiled and made the analysis of in terms of what we have in front of us. That should help you get an idea of where we are moving. I will just read out. Okay. I have shared this document with all the teachers also, so all the teachers are knowing that. You also should know that. Maybe I can get it printed and we can print it and paste it off in the hall, in this room, at multiple places. The test schedule, on which day you will have tests. All the things that everybody should be knowing can be pasted on the walls. Unless you have a habit of pulling it off, it will remain. All right. You already know what is the routine. So in the time activity design, that is how do we design the time to perform certain activities in the pursuit of what we want to achieve. You know the routine. Okay. The insights from the routine is every day you have 11.5 hours of learning time, including classes and practice time. You have 45 minutes of fitness routine in the morning. You have 60 minutes of sports and games, time for sports and games. You have 4 hour 45 minutes of break time during the day. 4 hour 45 minutes of break during the day, of which ideally you should be sleeping for about 2 hours. You should learn to sleep 10 minutes, 15 minutes, half an hour, not more than half an hour of sleep in one stretch during the daytime. So in that 4.5 hours, 4 hour 45 minutes, if you practice to use sleep as a strategy, that will make your 11.5 hours very productive, and in the night you sleep for 6 hours. That you know, this part all of you know. Relaxation of routine will be done on Sundays. You will have relaxation of routines for Sundays. So we totally have 292 days, starting from Monday till the day before NEET, 3rd of May 2025. We have 292 days. In these 292 days, we have 41 weeks That means we have 41 Sundays. From 16th, that is Tuesday, we started actual preparation from Tuesday. From 16th July to 31st of March, that is when there will be one form of structure. After that, there will be nothing. You will be preparing from your notes, that's all. The entire month of April and 3 days of May, you will be revising your notes. So till the end of March 31st, we have 259 days, 37 weeks, that means 37 Sundays. Alright. So the routine that will be relaxed. Every Sunday, you have the flexibility to skip the 2 to 4 p.m. study if you have some personal work. If you have some personal work to take care, maybe you want to clean up your room, or you want to take care of your clothes, you want to organize some things, or you just want extra sleep, 2 to 4 session can be skipped on Sundays if you want. Don't skip it because you want to skip it. Skip it if you need to skip it. 2 to 4 is relaxation. Parents will come and spend time with you in that time only. So parents can come probably for lunch. They can spend time with you till evening, till 4 o'clock. They can stay till 5 o'clock, 5:30 also before you get into the 5:30 session. And done. Sundays 5:30 to 8:30. Also it is not a study session. 5:30 to 8:30 is movie. Any movie, whichever movie you want to watch. Alright. So it is not like 5:30 to 8:30 we will play motivational movies, education movies, nothing like that. All sorts of movies we can watch. Alright. Happy or unhappy? Happy, no? So I have requested for a projector for this room. Internet, surprisingly there is good internet connection here. So we can stream it. Projection can be done. This should be enough, no, for the screen. If we turn off all the lights, this will become a theater. Alright, speaker is anyways there. All that we need is a projector, which I have already requested for. You will not be able to think on which movies to play because you will not know which movies are releasing, which movies are available. Maybe somebody will decide. Entertainment movies, you can tell what kind of movies you want. So 2 to 4 and 5:30 to 8:30, relaxation time. Sunday there will be no class, there will be no lecture also. So 3 hours of lecture is removed, 3 hours of entertainment comes in. That makes it 8.5 hours of time left. 2 hours is given as a relaxation for you to rest or do your personal work, or if your parents come, all that is there. So Sundays will be 6.5 hours of studies. So I am calculating 6.5 hours of learning on Sundays. Alright. Though high intensity preparation is required, it cannot be a pressure cooker. Pressure cooker will lead to bursting of the chamber. Alright, there need to be enough relaxation also. So that is, the relaxation is only on Sundays. And there will be routine modification on the days of mock NEET. This one, the first one, because we did it in a hurry. You wrote the exam from 5:30 to 8:30. But what is the time during which actual NEET exam is conducted? 2 to 5:20. You enter the examination hall at 1:45. You will be given the answer booklets, question booklets and answer sheet at 1:45. 1:50 to 2, 10 minutes time is given for you to fill up all your details on the OMR sheet, so that during the examination time you don't have to waste time filling it. There will be 200 questions, so you get 3 hours 20 minutes. That is, you get 200 minutes to attempt the paper. 2 p.m. to 5:20 p.m. is the time of NEET, examination time. So that is the same timings we will follow for all the mock tests. That means on those days, on the days when you have mock exams, you will not have class, you will not have study session 2 to 4. Your play time of 4 to 5, and even the evening refreshment time of 5 to 5:30 is also consumed in test. So that 1.5 hours, 2 to 4 is still fine, because your 2 to 4 is still the study time only, so you are writing the exam. 4 to 5:30 what has been 5:20 what has been pushed. That 1.5 hours what you were supposed to have as a break, will be from 5:20 to 6:50. So you will still have 1 hour of time to play, half an hour break to have tea and refreshments. And you will come back at 6:50. Generally on regular days you will come back for the session 3 of learning, so practice session 3 at 5:30 p.m. into the hall. On the days of tests you will come at 6:50. That's all, no other big change. Rest all it will continue. Yeah, there are some instructions given, those things have to be followed. And learning and preparation management, I'll give you some analysis, okay? You have 11.5 hours of studies every day. On Sundays you have 6.5 hours of studies, correct? Not every Sunday parents are visiting. Parents will visit on alternate Sundays if they want to. If some of your parents are living far, it may not be possible for them to visit every alternate Sunday. So whenever they come, you have that 2 to 4 time. And after the second half, if you want to spend more time with your parents, you can skip the movie and spend time with your parents. So the second half is kept flexible. So 6.5 hours. Totally there are 41 weeks. Senior faculty will get 70 classes. That is, every senior faculty, there will be 30 visits. I have put out the schedule also, from which date to which date, which faculty will be here to guide you on that subject. So every senior faculty gets to be with you for 10 full weeks. 10 full weeks. That means 7 days minimum. I will be with you for 7 days. I will take 7 days of sessions. Chemistry will be for 8 days. When chemistry sir comes, he will have classes for 8 days. Physics will be for 9 days when he visits. And for 5 days will be, those 3 hours also are available for you to consolidate all the learning that you have made in the entire month. So 30 visits of senior faculties, at least 7 days of training for you. That means 7 into 70 days of presence of every senior faculty with you, complete presence. 210 hours of teaching, the teacher guided learning, 210 hours per subject. So for the entire duration, you have 630 hours of teacher guided learning for PCB put together. Till March 31st, you have 567 hours of teacher guided learning. It is more than enough to train students who have come from 10th standard to the level of NEET, if it is only teaching that we do. You understand? Why it should, why this much of teaching is enough. All right? Learning, duration of learning, lecture plus practice. So we already know for the entire duration there is 630 hours of teaching. Till March 31st there is 567 hours of teaching. Weekday practice time that you get 8.5 hours. For the entire duration, if you ensure that every single weekday, except Sundays, every single weekday, you are putting in 8.5 hours of practice. If you do that, in the entire duration, the total duration of time that you would have put in your preparation is 2,185 hours. Can you imagine the scale of that? With just 2 days, this is the 3rd day of our intensive preparation. Within 2-3 days, if you have been sincere in the last 2 days, which I feel most of you are, you can see the confidence change. You'll start feeling more confident about yourself. You'll start feeling more confident about navigating through the questions. Doing it for 2,185 hours. All right? Till March 31st is 2,127 hours. So only Sundays, if we look at it, 266 hours for the entire duration, 240 hours till March 31st. So total practice duration for the entire course is 2,451 hours. 2,451 hours, your practice, not including teacher assisted practice, not including teacher assisted lectures. You add that also, for the entire duration of the course, total learning time that you would have spent teaching plus practice is 3,081 hours. 3,081 hours. All right? If you are sincere, Even if you are starting to learn to read and write now, 3000 hours is more than enough to be well prepared for NEET. You understand that? The power of routine. This is the power of routine. Why I am giving you the whole picture is because to tell you, you just have to do one session at a time. It is like winning the World Cup. Do you think about the finals when you start the World Cup? What do you think about? What do you have to think about? Huh? Today's match. Today's match. And okay, you have to play today's match. When you go to play the match, do you think about the final score that you will be scoring? What will you think about? You just have to worry about the ball that you are facing. Every ball, if you play according to its merit, by the end of the match, you would have made a very good score. If you decide that this match we will score 350 in 50 overs. What if the pitch is a very difficult pitch? 2 overs you are not able to score even 3 runs or 4 runs. You start getting irritated because you are calculating 350. You want to make 7 runs per over. Then the third over you will forcefully try to hit the ball. You will get out. All that you have to do is stay put. Hold on, keep playing every session, session by session. So when you come at 5:15 for your fitness routine, that's a victory. Those small victories you have to get. All right. So how many such opportunities you have to win every day? Waking up at 5 o'clock, 1. Coming to the fitness session at 5:15, 2. Being here exactly at 6:30, 3. 6:30 to 8:30, being focused, 4. Being here at 9:30, 9:30 to 12:30 focused, 6. Same for 2 to 4, 8. Same for 5:30 to 8:30, 10. 9:30 to 11, 12. You have 12 opportunities for victory in a day. All right. You count it 12 into number of days. Let's say if God is keeping account of it, how much you deserve to achieve your dreams. The percentage of victories that you get in relation to the possibility of victories that you could have had is your worthiness. That is what you deserve. So all that you have to make sure is stick to routine. 5 o'clock you wake up, celebrate mentally. You don't have to dance every time. You don't have to dance 12 times a day, annoying your roommates. All right. So that's all. 12 victories you achieve every day. That's all. All right. So you get that 3081 hours. 3000 hours you would have crossed. And there will be times when you put in extra time on Sundays. If your parents are not visiting and you don't have anything else to do, you get 2 hours extra. Let us cut down 81 hours also. 3000 hours you have. One thing you should congratulate yourselves is last 2 days you have stuck to the routine. You have stuck to the routine and you have done what you are supposed to do. So right now, even as of now, as we speak, you don't have any negative balance. Don't build any negative balance. Do every session, do everything that is given in the routine like that as it is. Okay. So you get this. Then test schedule. Like I told you, the dates will be put out. Till we complete, okay, there is some, all right. Till we complete the previous year NEET papers, the number of questions will be 180, except the last 3 years, 21, 22, 23, 24. The last 4 years, the questions have been 200 questions. 200 questions. I have not factored in this. Anyways, okay. But the time duration will still be the same, 145 to 520. All right. So till then, it will be 180 questions, and after that, it will be 200 questions. All mock papers that you will practice. Totally, you will have 62 papers till March 31st, 2025. 62 full-length, full syllabus papers. All right. How to go about doing that? How to go about preparing from that? All that we have already discussed. There is no need to discuss it any further. Of the 62, 13 to 20, That is 8 papers will be 180 questions. Rest all 54 papers will be 200 questions. So from the 9th paper onwards, your marking on the OMR sheet should be specific to the paper. Part A, Part B, all of that will be there. Alright. So 62 papers. With those 62 papers, you know how many questions you will be doing? 12,240 questions. Total. 12,240 questions. I told you, even if you are not able to answer, read the questions repeatedly. Even practicing the reading of these questions and understanding the questions completely is itself a good preparation. So don't think about whether you are able to do something, not do something. No, don't worry. 12,240 questions. Of that, 11,120 questions will be of, no, not 11,000, 6,120 questions will be biology. 3,060 questions will be physics. 3,060 questions will be chemistry. Massive. Number of questions that you would have attempted is massive. And if you are sincere in doing post-test analysis, making notes from that, there will be nothing that can come in the exam outside of your notes. Trust me on that. All that you have to do is build your linear notes, like I told you, syllabus map, level 1, perspective based notes. Build your post-test analysis notes. Nothing can come out of your notes. Even if 1 or 2 questions come, enjoy. Congratulations to the examiners. Alright. 720 is good. We will take 716 also. Correct? We don't mind. It's okay. We will eat 5 grams of sweet less. You will still be able to get into AIIMS. Imagine all 48 of you getting into AIIMS. Huh? Why not? Do you have to pay money to dream? You don't have to pay money to dream, no? All 48 of you in AIIMS. AIIMS Delhi has only 75 seats. 48 out of 75 from this. Why not? Alright, let us not go too far. But dream. Let it make you happy. When you feel sad, think about it. And don't attach too much emotions to your dreams. Don't start feeling afraid of what if it doesn't happen. Just keep dreaming. Dream, but work. Don't take a break to dream. Sir, I want to dream about him. So now I'll take a break. 3 hours I will not study, I will just dream. Alright, this is done. Then the next one is senior faculty schedule. On which days, who will be here. All of this will be put out. Alright. So, done. Any questions? Any questions related to what we have done so far? We will move ahead. Nothing? Alright. There are a lot of things that I have already discussed, so which are the foundational principles of learning biology. I'll hold back on photosynthesis and respiration for now, cellular respiration. That will make it more complicated for you. We will make it a little bit easygoing for today. We will discuss human physiology as a story and filling in some details, all the systems, all right. Again, when we discuss physiology, what is anatomy? Anatomy is the structure. Physiology is the function. The function necessary to carry on the survival activities. Correct? So, human beings are a bit advanced organisms. We operate at multiple levels. We operate at the level of instinct. See, there are, when we look at the involvement of higher faculties in living life, there are different levels of involvement. One is the level of instinct. What is an instinct? What is an instinct? An instant reaction. Where did you learn it? Where did you learn it? Can I say reflexes are also instinctive? Automatic instincts are reflex. Can I say that? If a small stone comes your way as you are riding your bike, what do? You look at it. Oh, stone is coming towards me. Will it come and hit me or not? It's coming closer. Okay, I'll duck. You do that? Do you do that? What do you do? Instant, automatic. You act and then think. You don't think and act. What the actions driven by thought before action, what is driven by thought before action is operating at the level of intellect. The responses or the actions which are done first before thinking. Thinking comes after action. That is instinct. Alright. Somebody is irritated, somebody comes and scares you. You are walking on the street, somebody comes and scares you by making a loud noise. What would be the response by instinct? You beat them. That is the response by instinct. It is just like you scare a dog, what it might do, depending on how much it is scared. It first tries to jump away. If you are too close and obstructing its path of escape, what will it do? It will bite and then run away. Is it like it is trying to escape and it looks at you, this fellow is standing in my way, he might harm me, I will bite and then run away? Is the dog thinking all that? No, it is just, it all happens in a flash, instinct. Somebody scares you, you just get startled, you compose yourself, you look at who it is and then scold them. Or you might laugh, depends on who is doing that. Alright, if it is your friend doing that, if it is somebody who you like who is doing that, then you enjoy that. If it is somebody who you don't like doing that, it comes operation, what drives our actions. That is the level of instinct, intellect and intuition. Intuition, what we feel, what we call as gut feeling. Right? Sometimes you are faced with a choice. Should I do it or not? Logically there will be something telling you don't do it. But there is some other motivation coming to you telling let's try. Let's try. For most of you, coming into this program is a choice of, is a decision made with a mixture of intellect and intuition. Logically you thought, okay, there is some program, residential program, I am anyways trying to take a break. There is no money for this, free of cost. So there are a lot of positives, but government program might not be good. I might be wasting my time there. Parents also might have had, you might have had this conversation with parents. Somebody would have told you, why unnecessarily waste a year, you are trying to take a year. It's okay even if you take a loan and go to a good coaching institute. Why go to a government program? You might be wasting time also and not do anything. But something told you, no, this might be good. Correct? Anybody who came with absolute clarity that it will be awesome. It will be awesome, I am convinced about it, I am sure about it. Anybody had that kind of conviction? You might not have even now. Okay? Logical conviction develops. You cannot start with a logical conviction. Everything that is beyond your existing range of experiences, what you already know of is what you can be sure of. Any new attempt, any new thing that you have to do, you will have to act with a mixture of logic and your gut feeling, your intuition. You have to listen to that. That's what, when intuition is referred to as listening to one's heart, follow your dreams. All of these are coming from intuition. Alright. So this is one thing. All organisms don't operate at all levels. All organisms don't operate at all levels. I am not discussing philosophy. I am giving you the context of understanding human body. Alright? Every organism operates at the level of instinct. Instincts are designed to survive. If you notice, all our instincts are associated with increasing our chances of survival. All our instincts are associated with giving us a quick escape from danger. That's all, no? You are hungry. Let's say 48 of you, you are getting 3 meals a day. You like it, you don't like it, it's up to your taste, not to your taste, that's all okay. But reasonably balanced variety so far is there. I am finding it a bit difficult because I am a vegetarian, I don't eat meat and there is meat 3 times a day. Alright, so it's okay. My needs are very limited, so I can survive, no problem. But what if all of you are starved for 5 days? Now you all go in a line decently. You go in a line, take your plates, take turns. If there is shortage, you know it will come. They'll replenish it. So you will take a little so that it is available for somebody else also. You can come back for the second round. All of that is coming there. You are operating from intellect. We don't give you food for 3 days. And suddenly in this room, let's say there is food made available which is sufficient for 10 people. Will you all allow the first 10 people to eat? Somebody from there might start jumping 3 rows at a time. Alright? The people in the front rows might feel people climbing on them also. Right? Instinct. Why do we do that? Why do we behave so in an uncivilized manner? Civilization is intellectual outcome. We decide, okay, let us put some rules, let us have some order so that we all will have a decent life. When survival is in question, civilization vanishes. There is no civility, there is no civilization, because either you fight for it and get what you want, or you die. Then you fight for it. That is instinct. All organisms have that. That is where an ant bites you if you hold it. That is where a bee stings you, even at the risk of dying itself, it will die. You know that, no? If a bee stings you, that is the sting is connected to its reproductive structures. So when a bee stings and tries to pull it out, it gets pulled away. Its body gets pulled out. So a bee dies. But instinctively it is designed to do that, because the bee, even if it knows that it will die, it can only act that way, because evolution has designed it in such a way that a few bees dying is okay to make the entire hive survive. Alright? So instinct. Where is it wired? All this instinct, intellect, intuition, all of these are related to the nervous system. The way things are regulated, the way the physiology is regulated, body is regulated, thinking is regulated, actions are regulated. All of this has some control in the body. Alright. So first thing is, to operate at different planes, we need to have some mechanism in the body. Philosophically speaking, we can talk about God guiding us or something else guiding us, all of that. But physiologically we need to explain it, no? We need to explain it physiologically, and we cannot bring in non-tangible explanations for physiological processes. We have to bring in tangible explanations. We have to bring in explanations which we can test and verify. So first thing that this body has to take care in terms of its function is what? Survival. Survival. Again, evolution. There are 2 forces of evolution. What are they? Survival and reproduction. That's all. Everything that is designed in this body is designed for these 2 only. So to survive, protection from dangers external, protection from dangers internal, and access to resources. Access to resources we need to have, and what resources need to be supplied to the body so that the body maintains itself. Correct? So we need to supply material to the body so that the body uses the material, breaks it and produces energy to carry out the metabolic processes, uses the matter, elements to build the mass. Growth, development, all of that is taken care of by, growth and development is taken care of by what? What will ensure growth and development? If I have to choose, if I have to tell you to choose one thing to do, you can only do one thing in life. Externally, other than what your body does by itself, you are allowed to do one thing. Whatever it is that you want to do, arrangements will be made for you to do that. What is that one thing you will do? Whatever it is that you want to do, arrangements will be made for that. But it's only one thing. You will be told, this is the only thing that you will be allowed to do. And arrangements for that will be made. That you have to, that is for your entire lifetime. What is it that you will do? Own business. Okay. Playing. Okay. Then cooking. Okay. I will try to stay closer where you are, because if I am told to do, what will you do? Food. If I am allowed to do one thing for my lifetime and nothing else, I will say give me food. Rest all my body will take care. Alright, you do business. That's all you are allowed to do. You are not allowed to do this. Okay. You want to cook? I will eat. Alright. So, that's all. When it comes to survival, all that we have to do is, for the survival of the body, for ensuring that this body functions properly, all that we have to do is take care of what goes inside. That's all. Rest all, the body has the intelligence to use it the way it is designed to use and build what it is supposed to build. Alright, how it takes use, how it uses it, how it makes use of it, all the rest of it. So this process of transforming complex matter into usable substances for the body is the digestive system. That's all. So we pump in complex food matter, it is broken down, absorbed into bloodstream. Okay, food has gone into the bloodstream. Done. For the digestive system, all that we have to understand is that, no? Right? When I introduce this digestion, school students, I teach school students also. Now I can teach up to 3rd standard, 2nd standard in my school. Further younger students is very difficult for me. I cannot handle very young children. I am slowly learning to handle them. It is very easy to handle graduate students, postgraduate students, MBA students, corporates. As you keep going lower and lower in age, teaching becomes more and more difficult. Anyways, when I introduce the digestive system to the school students, what is digestion? What is digestion? So go back 10,000 years, 20,000 years, when human beings did not know any of these things. We were all living in the forest. Suddenly one person got curiosity. They were eating only potatoes. They were eating only potatoes. He understood, he analyzed and understood there is one input and output channel for the body. Correct? Input and output channel for the body. So, he is eating potatoes. But potatoes are not coming out. Correct? So, he started thinking, alright, I eat potatoes and I get mashed potatoes. So, children understand digestion. Correct. What is digestion? Digestion is the process of converting potatoes into mashed potatoes. Now this fellow is more curious. He wants to understand what is happening. How is this getting converted? He sees a dead body. Somebody dies. He opens up the tube. Now he gets the tube, starting from the esophagus till the rectum. He extracts the tube. This is where potato goes. He will take a potato, push it inside. Push it inside, push it inside. Potato comes out. Oh, it is not just the tube. Tube is allowing it to pass, but something else happens which will mash the potato. Then gradually, step by step, as they understand, they get to understand the connections. What are the other connections there for the tube? What all are connected to the tube? There are two connections to the tube. This tube is not a closed tube from one end to the other end. It is not a closed tube. There are two places where it gets connections except the opening and end. Huh? There are two more connections that is connected to the tube. Intestine is continuity. Intestine is the tube only. He saw this from one end to the other end. So he understood the tube. Over. From one end to the other end, he understood the tube. There is one connection here and only one place where there is more connections established there. What is this? Stomach? What is this? The first part of duodenum, the first part of the small intestine, which is duodenum. What do you have here? Pancreas. What is that? Liver and gallbladder. So as this fellow started exploring, he understood there is some other connection here. Something might be coming from here which is mashing the potato. So he opened this part. Then he saw this is connected. This leaf is connected. Or bread is connected. Whatever you can think about it. Pancreas. Then he sees there is something else also coming to this. Then gradually they started understanding that it's all pipelines. This is an entire network of plumbing lines. Variety of plumbing pipes are there in the body. This is done? Clear? That's all. Let us keep it that. We will not go more deeper into this now. So digestive system is doing what? Converting complex food into nutrients. That's all. How it happens is the process. We will do that. After the outline, we will do all that. Then now the nutrients have come into where? Where do the nutrients come in? Absorption happens from the intestine. Where do the nutrients go now? Where do they go? They go into? Where do they go? Are these nutrients required only by the digestive system? Where is what requires these nutrients? Every part of the body requires it. Every cell of the body requires these nutrients. How do you make sure that the nutrients are delivered to every part of the body? Through the blood. So nutrients are entering the blood? No, not yet. Alright, let it be. Nutrients are going into a drainage. Now the drain is connected to the heart. Alright, it's a one-way drainage system. Drainage collected from all over the body goes into the heart. What is there in the heart? Heart has blood, and heart is connected to a network of pipes. These pipes are called blood vessels. Now these blood vessels carry blood to all parts of the body. Blood never gets out of the blood vessels. Then how do the cells get what they want? The cells have to get what they want. It is there in the blood now. First it was, the cells want, there are only two things, no. There are some needs for the cells which has to be supplied. What needs? There are no emotional needs for the cell. My neighboring cell is not talking to me, I am depressed. No. The cell wants nutrients. All the necessary things is required by the cell wants it. What the cell doesn't want is being produced inside the cell. The cell is producing some unwanted substances, metabolic wastes, that has to be removed. We are organisms who depend on oxygen for survival. Without oxygen, the cell will die. So the cell has to be supplied with oxygen, and the cell has to be taken away. The carbon dioxide has to be taken away from the cell. That's all. So you need a transportation mechanism, and everything is not available to every cell. Though the body is surrounded with oxygen in the atmosphere, the body cannot take in oxygen like that. Some organisms can do. Some organisms can do respiration through their skin. Can you give me an example of an organism which does cutaneous respiration? Frogs. Frogs can do cutaneous respiration. They can breathe through their skin. We cannot do that. Our skin has got a coating of keratin, the surface. The top surface has keratin. It is impermeable. You cannot have gas exchange. Now, all our cells require nutrients. All our cells require oxygen. And all our cells are producing metabolic wastes which has to be removed from them. All our cells are producing carbon dioxide which has to be removed. Alright? So there is a nutrient factory, there is a oxygen factory, there is a waste disposal unit, and there are cells all over the body. And there is one transportation system. That's all. If we don't look at the nervous system, a person can survive, a person can still be considered to be living after the person is brain dead. Correct? We have seen patients who are brain dead. That means what? Nervous system is not working. The higher function, brain is dead. Brainstem is working. Brainstem has all the centers for respiration, cardiac function, heart and respiration. Alright. So, we are moving towards understanding what functions is the body performing. And these functions are common. These functions are common for even the bacteria. So what did we bring it down to? Tell me what all at the cellular level. Let us analyze it at the cellular level. What we want, what we don't want. You are a cell. You are a cell. What do you want? You want nutrients. What else do you want? You want oxygen. That's all, no? Pretty simple life. Only two requirements. Supply me with nutrients. Give me oxygen. I don't bother about anything else, huh? What? Water. Correct. Water. Okay. What do you not want? At the cellular level, what do you not want? You don't want metabolic wastes, and you don't want carbon dioxide. That's all. You don't want metabolic wastes and you don't want carbon dioxide. Over. That's all is human physiology. How all of this is regulated is the nervous system and the endocrine system. Beyond that, survival is related to all this only. This is only related to survival. Nutrients, where is the source? Let's say this is the source. And let us say this is the sink. Alright, source and sink we talk about in which concept? Where do we talk about source and sink? We talk about something in respect to source and sink. Huh? Here I am mentioning source and sink because source is where you take something from, sink is where you discard something, where you throw something. Where else do we talk about source and sink? What? Transportation in plants. Do we talk about source and sink with respect to water transportation in plants? Food transportation. Food transportation. Are the source and sink fixed in plants? Is it unidirectional? No. It is not fixed, it is not unidirectional, it is multidirectional. And the source in one particular transport can be the sink in another process, in another pathway. But here, we will just look at it in terms of source and sink to understand where are we getting things from and where are we throwing it out. Clear? What is the source for nutrients? What is the source for nutrients? Food is okay. Food is the material from which is coming and getting dumped into the source of these things. Okay. Where are we getting these nutrients from? Inside the body you talk about it. Let us not talk about where are we getting things from. Okay. For oxygen the source will be atmosphere, no? For water the source will be rivers, no? Okay. Talk about it inside your body. What is the source for nutrients? Come on, what is this? You have to speak. Huh? Digestive system. Digestive system, predominantly small intestine. That is where most of the digestion and absorption happens. Why I mentioned digestive system and not the small intestine? Because there is some digestion and absorption happening in the mouth, digestion happening in the stomach, some absorption happening in the large intestine. So we will mention it as digestive system. That is where we get our nutrients from. Where do we get our oxygen from? Where do we get our oxygen from? Respiratory system. Respiratory system begins where? Respiratory system begins from here. Okay? Do you get your oxygen from here? Can you take in oxygen from the nose? No. Here we don't have to mention respiratory system. What do we mention? Lungs. Because oxygen is made available only in the lungs. No other place in the respiratory pathway you will be able to absorb oxygen. Now tell me, what do you call that part of the network of the respiratory pathway where gas exchange cannot happen? What do you call that space? That portion of the respiratory pathway where gas exchange cannot happen. What do you call that? What do you call that? And there will be portions of the respiratory pathway where gas exchange can happen, but it normally does not happen. So what do you call that? Okay. Conducting portions and gas exchange portions. Okay, what do you call that space? I'm giving you answer. Think. Recall. Okay, I'll give you a parallel example, okay? There is a person who is not responding to any stimulus. What can that person be? What can that person be? What can that person be? He is not responding to any stimulus. You are calling, you are shaking him, you are pinching him, you are putting water on him, not responding. What might that person be? Dead. Correct? There is a person who is breathing, walking, talking, but does not respond. What do you call the space in the respiratory pathway where gas exchange cannot happen? Some people cannot respond, some people don't respond. Some part of the respiratory pathway cannot carry out gas exchange. Some part of the respiratory pathway does not carry out gas exchange normally, but it can, it doesn't. Oh. Dead space. Not heard of dead space? Not heard of dead space? The part of the respiratory pathway where gas exchange cannot happen because of the structure, because of the thickness of the wall of the passage, is called anatomical dead space. Anatomy is structure, no? The structure will not support gas exchange. The membrane across which gas exchange happens should be very thin, because gas exchange happens by partial pressure gradient. But the part of the respiratory pathway that is in the lungs, mostly at the apex of the lungs, where gas exchange can happen, but it normally does not happen because we don't inhale so much of air to ventilate our apex of the lungs, ventilate the apex of our lungs. So it is designed to bring about gas exchange, but gas exchange normally does not happen. Such space, dead space, is called physiological dead space. You get that? Anatomy is structure, physiology is function. Functionally it is not carrying out gas exchange, so it is called physiological dead space, mostly at the apex of the lungs. Structurally it is not capable of bringing about gas exchange, then you call it anatomical dead space. Get that? So where do we get our oxygen supply from? Lungs. Human physiology and relate. These are the only two places where we put something into our body, no? Unless we are ill and we are in the hospital and there is an IV line and we are pumping in. IV line, whatever goes into your body through the IV line is monitored by doctors, so nothing bad can go in. But what we pump in voluntarily, a lot of bad things can go in. Correct? Sink for metabolic wastes. What is the sink for metabolic wastes? See, metabolic wastes, we will do one thing. We will also write it as food wastes or undigested food. Metabolic waste and waste as a residue of undigested food are different. Metabolic wastes are produced at the cellular level. Undigested food is the leftover in the digestive tract. What doesn't get digested or what cannot be absorbed, all of that has to be thrown out of the body. That's all, no? So what is the sink for metabolic wastes? What is the sink for food waste? Where do we throw this from? Our digestive tract only. Large intestine, digestive tract is the sink for food waste. What is the sink for carbon dioxide? Lungs again. It goes into the lungs and it is removed. What is the sink for metabolic wastes? There are major sinks and minor sinks. There are multiple sinks. What are the sinks for metabolic wastes? Number one sink, most efficient, biggest company, Reliance of waste management is kidneys. The Reliance of waste management is kidney. There are smaller companies also. What other companies are functioning for removing wastes? Which organ in the body is called the metabolic factory of the body? Metabolic factory. It will not only help in waste management, metabolic waste management, it will also help in production of a lot of metabolic substances required by the body. And this is the organ which has the highest regeneration capacity in your body. Liver. Liver is on the left side of our abdomen. Correct? Liver is here. Correct? Liver is on the left side of our abdomen. Right? Right or wrong? Where is it? On the right side. Below the diaphragm or above the diaphragm? Below the diaphragm or above the diaphragm? Below the diaphragm. Can we feel it outside of the rib or is it under the ribs? It is under the ribs. But under the ribs there should be lungs, no? Is our chest cavity filled, is our ribs covering only the lungs and heart? There is enough space, the diaphragm is here. Alright, so yeah, liver is the metabolic factory, so liver also participates in waste disposal. Liver also is a place where there is a lot of metabolism happens, metabolic wastes happen. When you, let's say somebody who is a chronic alcoholic, what is the person likely to develop disease? Huh? What? Liver cirrhosis, fatty liver, all of that. So liver is handling this alcohol, liver is breaking down alcohol into aldehydes. Aldehydes are further broken down into safer metabolites to be thrown away. Aldehydes are very damaging on the body. So liver is the first point of contact. It is like if you are a person who is supposed to handle toxic gases, you are always in the chamber where you are facing toxic gas. You are more likely to get ill than somebody who is far away from that. So liver is like that. Liver is the first point of contact. Whatever we absorb from the digestive system passes through the liver and then goes into the heart. I told you, there is a drainage facility. That drainage facility is passing through the liver and reaches the heart. What we absorb from the digestive system is not directly going into the blood. See how beautifully it is designed. Nature knows that we are all lousy eaters. We eat whatever we want. Okay, we put in a lot of toxins into the body. If we allow all that is absorbed from the small intestine to come directly into blood, what is the risk? When it comes to blood, it will go to heart will pump, blood will go everywhere to all parts of the body. Every part of the body will have to deal with toxins. You understand? Every part of the body will have to deal with the toxic substances, and there are so many sensitive parts in the body, sensitive organs in the body. So there is a design that is made to ensure that whatever is absorbed from the small intestine goes through a separate network of drains which are running parallel to the blood vessels. These drains are running parallel to the blood vessels. These drains get into the liver. In the liver, there is some first level of screening that happens. So if there are toxins, it is detoxified. So liver is the detoxification center of the body. Alright, liver cleansing, keeping the liver healthy is therefore very, very important. So after all that cleansing is done, then it goes to the heart, and that drainage is poured into the heart. The drain opens into the heart in the right atrium. So right atrium gets superior vena cava, inferior vena cava, and this drain also. Now all of that mixes into blood. Whatever has been absorbed from the small intestine passes through the liver, gets some initial garbage treatment or sewage treatment. Alright, treatment is done. Then a treated fluid comes into the heart, is poured into the heart. From heart it goes everywhere. Like it goes everywhere, whatever is pumped in the heart, a part of it goes to our reliance also. Kidney, our main waste disposal system. Kidney is equipped with more mechanisms to remove everything that is unwanted. Like we discussed yesterday. Like everything is removed, kidney is designed to identify what is necessary for the body, take all of that back, what cannot be identified is left behind. That fellow might say, oh boss, I am very useful to you, I can make you make a lot of money. Do you have an ID on you? You don't have an ID, get out, I don't care. That's all. Alright. So, kidney. Metabolic wastes are eliminated. Not only kidney and liver. So if we consider, kidney is the #1 metabolic waste elimination factory. Liver is the detoxification factory of the body. Not only that, if you are, let's say if you have consumed alcohol and you are driving, police will stop you. They want to find out whether you have consumed alcohol or not. Where did you take alcohol into? How did the alcohol enter your body? Did you inject it? No. How did why you? How did the person take alcohol? Now if you start answering these questions, it will imply that you have consumed alcohol and you are caught caught by the police. Let us say somebody has consumed alcohol. He has been caught. How did he consume alcohol? He drank it. Okay, he drank alcohol. Where did it go? Into his stomach and then intestine and got absorbed into. Did it get into blood? It got absorbed into the drainage system. What is the drainage system? We will see. Right now you just remember it as drainage system. It got absorbed into the drainage system. Through the drainage system it went into the pipeline that goes to the liver. It got treated in the liver. So liver is trying to break it. The loading is so much that liver is not able to break everything as it is passing. It is just as it is passing, it has to break. So there is too much. So it goes into where? Heart. From the heart it is pumped and goes to various parts of the body. As it is going to various parts of the body, it reaches the brain also. Then he will start speaking slurry speech. Then he starts moving clumsily. All of that will start happening. That is sin. But what is the police constable who stopped this person checking for? How does the person know that this person has consumed alcohol? By what? Are they taking blood samples? Huh? Breath. How did alcohol come to the breath? It went into the digestive tract, got into the drainage system, got into blood. Wherever the blood is reaching and it is affecting different organs. But how did it come to the breath? What if he washes his mouth with Listerine? He does mouthwash after drinking. Can he escape? Assuming he was drinking alcohol, so there was alcohol coated in his mouth and there might be that smell. If he washes his mouth thoroughly, salt water gargling 25 times, will he escape? So that means it is not alcohol coated in the mouth. It is coming from the lungs. If breath is having traces of alcohol, that means alcohol has come into the lungs. Not as liquid alcohol, but alcohol has vaporized into the lungs. That means from the blood, not only carbon dioxide, alcohol also has diffused into the lungs in vapor form. Understand? Have you noticed when you are ill and you are taking antibiotics and you are taking a lot of medicine, have you observed the change in the smell of your mouth breath? Is there a change in the breath odor? It will be smelling like medicine. You will know by the breath of people whether they are taking medicine or not. There will be change in the taste of your mouth. You will be tasting medicine. You did not chew it, no? Then how are you feeling the taste of it? Is it psychological? So, the third sink for metabolic wastes is lungs. Lungs, skin. All of these will function like metabolic waste eliminators. Kidney is the primary one. Alright. So nature has designed it. Input only one channel. Because you can put any amount of things, you have control over it. But once things enter into the body, heart has to pump blood. It has come into bloodstream. Everything will come into the bloodstream. Once it comes into the bloodstream, it goes everywhere. And how much is the fluid that is going into the kidney per minute? Kidney is filtering out 125 ml. Correct? Of all the blood that is going everywhere in the body, part of it, very small part of it goes to the kidney in every cycle. Correct? So everything that has got into the bloodstream cannot be removed by kidney once. It will be removed by multiple cycles of blood going into the kidney and coming out of the kidney, going to the heart, being pumped again, going pumped again. Dilution happens over a period of time. What if there are some very toxic substances that have entered the blood? Can the body take chance of the kidney alone taking care of this quickly? So body has designed mechanisms, nature has designed mechanisms, evolution has led to the development of mechanisms which can remove toxins at multiple levels. Liver will detoxify, it will try to break it down, it will try to change the nature of the toxin into the chemical into a different chemical which is safer, less harmful. Kidney outright it will throw away, kidney will remove it, but if it goes to the kidney it will remove. What will you do with all the things that are circulating? Under the skin, the capillary network that we have under the skin is very exhaustive, very extensive network of capillaries under the skin. So, skin is also given that capacity to function as elimination organ. So, the surface area available on the skin is very big. It's a big surface area that we have, and it is exposed to the surroundings. So, what can be eliminated through the skin has a higher chance of being removed. Initial evolution, where did it happen? Did it happen on land? Initial evolution happened in water. Initial evolution happened in water. So now think about it. If my skin is also removing some toxins, I am in water. What is happening to the toxins? Being removed from my body quickly. We have come out onto land, but our ancestors, our earlier evolutionary ancestors, have spent millions of years in water also, no? All life evolved in water, and these are all mechanisms which have developed. Alright? It is not be prepared for everything, it is prepare as you get exposed to challenges. So that you are prepared for that challenge that you are exposed to, and you are ready to face new challenges and learn from it and increase your arsenal of weapons to deal with challenges. This is the way of evolution, no? Has nature thought about it? Oh, these are the things that we have to be prepared for. We will prepare for all that, and then nature decides, we are ready. I will create life now in its perfect form. Does that happen? Life has evolved. Can you correlate this? How our bodies have become more and more efficient to the nature of preparation that I have designed for you? Okay. Attempts to be prepared for something, worrying about not being prepared for something is unnatural. That's not how it happens in nature. You just go face it. Be sincere. Nature is sincere. Nature will learn from everything. It's constant. If artificial intelligence can learn so much, natural intelligence has much more complex ways of gathering information. So if you are sincere in responding to challenges and build your arsenal of weapons to deal with future challenges, over a period of time, you will develop like the immune system that has developed in our body. How is the immune system? As we are here, we are getting exposed to a lot of infection. It is fighting. Something new we get exposed to, it will identify and build tools to fight it. So this is clear? Now tell me, what is the system that helps us get nutrients and water? It is the digestive system, correct? Whatever comes into the digestive system goes into what system? System of drains. What is that system called? Anybody? We'll do hangman. Okay? We'll play hangman to get to that. What is the system of drainage all over the body called? Okay, I'll ask you something else, okay? And this system is not only drainage system. This system has police stations. This system has defense stations in its network. This system will respond first to any attack. This is the first responder system to terror attacks. And this system is spread out all through the body. And it is a one-way system. It is not a closed system, it's an open system. Starts at the level of tissues, ends in heart. What is this system? Lymphatic system. It is the system of lymphatics. What do we have in lymphatic system? Three things. Lymphatic vessels, lymph, the fluid, and the third one is lymph nodes. Lymph nodes are lymphatic organs, you can say. Not only lymph nodes, which is the biggest lymphatic organ of the body. Biggest lymphatic organ of the body. You remove that, immune system will become very weak, because this is like the this largest lymphatic system of the body is like the biggest platoon of your defense force. Huh? What? Thymus. Thymus is the defense academy. Thymus is the National Defense Academy. All right. Or even you can say thymus is like the train the trainer defense academy. Bone marrow is the National Defense Academy. It remains. Thymus goes. It will get shut down quickly. So thymus is not the lymphatic organ. It is primary lymphatic organ. Okay. Secondary lymphatic organ. Which one is the biggest? Starts with S. Spleen. Spleen. Okay. Now lymphatic system is a drainage system. Whatever is absorbed from the small intestine goes into the lymphatics. And those lymphatics which are draining from the small intestine connects to portal vein. Portal vein is the vein in the liver. From the lower limbs all these veins come and join, and here in the liver it becomes portal vein. Portal vein goes through the liver and that connects to the inferior vena cava. But rest of the lymphatic network will connect and form the biggest lymphatic vessel, which will open into the heart. What is that called? Thoracic duct. Thoracic duct. Alright. Those who are not getting it, don't worry. We will go into details a bit more later. But are you getting the story? Are you getting the story? What all systems are participating in the survival of this body? Higher functions, nervous system we will not touch. Alright. We will talk about the survival need and the system participating in that. The first survival need is food. The system participating in that is what? Digestive system, making nutrients available. The second system necessary is transportation of material. Transportation of all materials in the body. What is participating in that? Circulatory system. Circulatory system has three things. What are the three things in the circulatory system? Heart, blood vessels and blood. The pump, pipes and the fluid. That's all, no? PPF, pumps, pipes and fluid. PPF is also Provident Fund. Alright, okay. Then, drainage system in the body is drainage and immune contributing system. Immunity contribution system is the lymphatic system. Lymphatic system. Then, the system of gas exchange, supplying oxygen and eliminating carbon dioxide. What is that system? Respiratory system. Respiratory system is helping us to get oxygen and remove carbon dioxide. And the excretory system, the renal system, helps in eliminating metabolic wastes. For excretion of metabolic waste, we have to consider kidneys, liver, lungs and skin. All four we have to consider. Kidneys is the most important, predominant. Liver is for detoxification, and detoxification also helps in elimination, not directly but indirectly, by making the toxins less toxic. Skin and lungs partial elimination of wastes. Whatever they can, they will do. Alright? And all of this is controlled and regulated by the nervous system and endocrine system. One major difference between the nervous system and endocrine system is, nervous system is a hit and run case. Endocrine system is a continuous force. Okay? Hit and run means what? Nervous system acts and it removes. Endocrine system is stimulated by nervous system again. But whatever impact endocrine system brings about is permanent and irreversible. So many hormones have helped you grow, no? Growth hormone, different hormones have helped you grow as individuals. If the hormone ceases to exist in your body today, will your growth reverse? If growth hormone is no longer produced, will you become a 2 kg baby? No. Whatever has happened has happened. Endocrine system is for continuity, nervous system is for impact. So both of them together will regulate. Regulation of the body happens through nervous system and endocrine system. Right? You get the whole picture now? Some small bits and pieces here and there. Purpose is what we have to identify, and how is the design for the purpose? How is the performance of actions to fulfill that purpose? Design and action are the two things we have to study with everything. Purpose, design, action. Purpose, design, action. Alright. If you understand, human physiology is associated with understanding these three. Anything that you want to study, you have to first understand what is its purpose, how is the design to fulfill this purpose, and what is the action being carried out to fulfill the purpose. Okay? Done. The outline of the entire human physiology is done, and in all this, because we are motile organisms, we move, we have locomotion, we have locomotory system also. Locomotory system is made up of the skeleton and the muscles. Muscles again, based on the purpose, three types of muscles. What are the three types of muscles? That which helps in moving the skeleton is skeletal muscles. That which helps in moving the heart, cardiac muscle. That which helps in moving everything else, smooth muscles. Everything else meaning the internal organs. All the movement of anything, movement of the organs or any movement in the organs is brought about by smooth muscles. That's all. With muscles, what needs to, the functions that needs to happen automatically without your thought will be regulated by involuntary muscles. The functions which needs to happen automatically as well as also voluntarily, like moving, walking, skeletal movements, those are controlled by skeletal muscles. Nothing in your body is absolutely autonomic. Nothing in your body is absolutely autonomic. Autonomic means voluntary. Nothing is absolutely voluntary. Every voluntary function that you have in your body has an involuntary component associated with it. You understand? There was an attempt to kill Donald Trump. You are aware of it? It was when you were at home, before you coming here. Do you have any role in that? No. She is seriously answering, no, I don't have any role. You saw that video, did you see that video? He ducked, he had turned, and by the sound of it, he ducked in the direction opposite to where the bullet passed. Not that he ducked and then the bullet passed. The bullet passed and he ducked in the opposite direction. He escaped not because of ducking, he ducked because of the sound. So fortunately he wanted to see something on the screen. He turned and then the bullet passed. Otherwise, alright. So that was the involuntary. You go into a movie theater, you are late by 5 minutes. That's a very painful experience. You go to the movie theater and the movie has already started. Heartbreaking experience. All right. So what do? We have taken so much time to enter the hall. It will take us another 10-15 seconds to reach our seat. But no. We are looking at the screen and then walking, and suddenly there is a step and we miss it. What have you experienced that? How did your body respond? It automatically goes into a balance mode. Correct? It automatically goes into a balance mode. Then you start thinking, first let me go and sit. Otherwise, I will become the movie. All right. So you go and sit and then start annoying the person sitting next to you. Punish those who came on time. What happened? What happened? All this. So your locomotion is voluntary. But when it comes to a point where you might hurt yourself, voluntary function overrides, voluntary function is overridden by involuntary control. It's like autopilot mode in flight. When you are not able to control, it will automatically take into an autopilot mode and it will start controlling. So beautiful design. All right, anything that humans have created is not as complex as humans themselves. So that's the beauty of human life. All right, all the systems we have touched upon. Now you should look at the entire body as a whole. Now we have different systems. We have touched upon cellular functions also. Cell also we discussed, different functions. All of these functions are happening inside the cell also.